I'm going to jump ahead in the textbook a little bit to 3.3 and just talk about a term that I mentioned at the end of our last video called the LCD, the least common denominator. So to add or subtract unlike fractions, which we're going to be doing here in just a couple videos, we first write each fraction as an equivalent fraction. That's what we're going to be doing in our next video with a common denominator. The common denominator we use is called the least common denominator, the LCD. So I'm just going to do a couple examples here from this vocabulary review check that we do in my math lab to see if you understand what an LCD is. I'm just going to do problems 3.3, VRC1, VRC2, and VRC3, where VRC stands for Vocabulary Review Check. So these are based off of section 3.3 in the textbook, which is a little ahead of where I'm working problems from, but I think it's important that we just go ahead and talk about this now right after we did LCM because they're so closely related topics. So the LCD for 1/6 and 5/8, this was that definition that I just read to you, is, and we're going to look at, really, we're asking what the LCM of 6 and 8 is really almost an equivalent question here. So the least common multiple for them is going to be 24, because 6 times 4 is 24 and 8 times 3 is 24. Not sure if you've seen parentheses for multiplication before, so I'll go back and use the multiplication dot. That's the first multiple of 6. It's also a multiple of 8. So the answer here is 24. And for this last problem here, the LCD for, let me make this up, 1/3 and 2/15 is going to be 15, because 15 is the LCM of 3 times 5 is 15, and 15 times 1 is 15. So just so you have an idea what an LCM is, when we start talking about that in just a little bit, there you go. We have a definition that it is the denominator that we're going to write for our equivalent fractions, that is the lowest common denominator that those fractions could have. And that's going to help us not have to do as much reducing at the end when we go back and write our fraction in lowest terms at the end of the problem. All right, just thought I'd come back and talk about that term that I used at the end of the last video. We're going to go back now to section 3.2, and we're going to pick up talking about equivalent fractions now.